Hey guys, what's up? Eddie Aho here with KissAnalog.com. Alright, today we have Hioki in the lab. It's pretty cool. What we're going to do today is, I have this DT4282, it's their high-end meter. We're going to do a box opening and a teardown, okay? And because the video is going to go long, I'm going to, one reason it's going to go long, I'm going to compare this to a Fluke. I think the Fluke 189 compares very nicely to this. You can still buy the Fluke 189. The prices are similar, so I think that's a good comparison. It takes a little longer when I compare it to another multimeter, but I feel like using a meter that people know or a brand that people know, they have a bar that they can compare things to and they can see for their eyes like how things compare. Let me know if you like this format. If you don't, I can go faster if I'm not doing this, or if you need less detail, you don't need to go. Yeah, let me know all that stuff, okay? Leave your comments below. I appreciate that. That's what we're going to do today, is just box opening and teardown, right? When I reviewed this video, it was a really long video, the DT4256. It's an awesome meter, 6,000 count meter, lots of features, a filter, all kinds of things. And they're very fast meters with very nice display. Nice physical size. This one's larger. This guy's their high-end meter. This is the highest end that they have. I reached out to Hioki and I asked them for some samples if they had that. They said sure. And then they emailed me and they said they looked at my videos, they liked what I was doing, and they're going to just send me the meters for free. So no strings attached. They didn't ask me to say anything or anything like that. So I think that's pretty awesome. Just want to throw that out there. Okay, so why is this their high-end meter, and why, what's so cool about it? Because I think it could be the Superman of multimeters. If it performs to its spec, like the DT4256 did to its spec, then I think this is going to be, like I said, the Superman of multimeters. The Fluke 189 has always been my favorite Fluke, and it just turns out that they compare very closely, and so even in price, like I said. So I think it's a great meter to compare it to, and it's rare that I find a Fluke that I compare feature for feature that the other meter doesn't, meter B doesn't cost a lot less. But the Fluke 189, it's priced, the price on it is probably a 10-year-old price. But they're still, like I said, you can still find it for sale. And so I'm really excited about this. I want to get this out of the box, start using it on the bench. I think it could be the perfect meter for an audio guy or a power supply guy like myself. That 100 kilohertz bandwidth is just amazing. This guy has a 1 kilohertz bandwidth. Most multimeters have 1 kilohertz bandwidth. Now, I think this might go out to 2 kilohertz or maybe even 3, I forget, since the review. But most meters kind of fall within that range, where this guy, and some meters right at 1 kilohertz, they just drop off. But this guy seemed like he kind of tailed off slowly. This one's 100 kilohertz bandwidth. Fluke 189 has nice bandwidth too. This is 60,000 counts versus 6,000 counts. And yes, I know people say, hey, resolution, the counts and accuracy, they don't go hand in hand. They're not the same thing. Precision, they're different definitions. I understand that stuff. They are different parameters. They're different definitions. But it's like you don't get a sports car without having a sports car engine, a high horsepower engine in it, right? You don't get a Ferrari engine in a Volkswagen. So if you have a Ferrari engine, a high count engine in your multimeter, chances are it's going to go pretty fast. It's going to have, good accuracy. And if you look at the Flukes, and the Fluke actually sold me on this idea years ago, because back when instead of calling them counts, they call them digits, right? That's a 3.5 or 3 3/4 or 4.5 digit meter. And I bought a 4.5 digit meter from him because I thought, man, I want that accuracy. I want that extra couple of digits or whatever. Because you always have to remember that last digit or two, when you look at the accuracy, there's a percentage, right? It might be 1%, 0.1%, whatever, 0.025%, something like that, plus 1 digit or 10 digits. So if it's 1 digit, that last digit means it can go up and down by, if it says 5 digits, it means it go up and down by 5 digits. And if it's 10, the last 2 places, the last 2 digits can, move. So, yeah, anyway, get off my soapbox, but 60,000 count, like the Fluke 189, you'll see on the specs that they, like the Fluke, their accuracy is higher in their higher count meters than in the lower count meters. It's just the way it is. A sports car just goes faster. So yeah, maybe not in every single case, but I like to know the cases where they don't. You know, you might have a really inexpensive meter that somebody's beefed up the count rate or something like that, and they've cheaped out on everything else just to try to, you know, trick you in a high count. But I don't know of that meter yet, but I'm sure they're out there. At least I'm guessing they are. But let's get back to this. 100 kilohertz bandwidth, 60,000 counts, has decibels, it has the filter. I hope it's a fast meter. I hope that I just hope it performs as well as this guy did, because I just want to use it on the bench. So, oh hey, before we jump over here and get into the video, give a video a thumbs up, subscribe if you haven't done so, I appreciate it. And if you don't like the meter, yeah, don't give it a thumbs down unless you don't like the video, then you can give a thumbs down. But yeah, the thumbs up, down isn't a vote for the meter, you know, it's for the video. So it helps the channel when you give a thumbs up, appreciate that. And let's jump into this review. Okay guys, so let's go ahead and open up this box. I'll just show you the box in case you want to, if you're interested in seeing the different sides. Japanese company, made in Japan. Imagine that. So the 82 model has all the features. This guy, the 81, has a clamp in feature, kind of like this 4256 model. Okay, so just put that here just for kind of reference. Yeah, there we go. Drop test on concrete, 1 meter. That's nice. Not all meters have that. Not all Flukes have that, by the way. A lot don't. And it has a filter function. You can see all the things it has. Okay, so there you go. Let's just open this bad boy up. Okay, that's the way it comes packaged. Pretty nice and neat. There's the meter. So definitely bigger display, but not too bad in size actually for what kind of meter it is. Okay, what else we have in here? Alright, so batteries, test leads, and all kinds of documentation. And by the way, these instruction manuals are really nicely written. They're very nicely written, guys. And this is all in English, so this is an English one. It doesn't share a bunch of languages, so look at that. 107 pages plus the appendix. So it's a pretty thorough instruction manual, and they have it online as well, obviously. I think it's in color online. So I think these are the same test leads that came with this meter. They're not silicone, but I'll tell you what, they're very flexible PVC. Very nice. And these caps, they're gold tipped, if you can see that. Might be hard to tell they're gold tipped, but they're gold tipped, and these caps are snug, but yet, you know, not hard, super hard to get off, but they do fit very nicely, you can tell. Okay, and the other thing about them is on this end, they do have that protective little plastic cap in there, so they're made very nice. They have these grippy things on the sides. Nice tension relief. Yeah, pretty nice leads. And 4 batteries. So we can tell how many batteries this takes right off the top. 4, wow, look at that, double A's. So, and the Toshiba batteries. Toshiba is a great brand, so I would assume those are good batteries. The manual can take some time, and the specs are pretty detailed. So I'm just going to show you. Here's the accuracy table for AC voltages. And most people brag about their accuracy when they're talking about the DC accuracy, and that's what we get here. So yeah, I'm not going to go through the manual. We'll probably see spots of it during this review. Alright guys, before I put the batteries in, I just wanted to kind of compare it to another meter. The Fluke 189 probably cost about the same back in the day. Could have been slightly more, but anyway, it's really my favorite Fluke meter, but you can see the size is the same. The back, the construction's similar. They both have the meter lead holders. The Hioki comes with the build-up rubber here for support when it's laying on its bottom. It's got the build-up rubber down here. The Fluke has the buildup rubber here and here, but it's kind of interesting it's here. I guess if you take this off to lay it down, but this is that comes off pretty easily too, by the way. A little bit too easy, I think. It's real soft rubber, but this is where you'd put the magnetic holder. So yeah, I'm not sure if I'd trust that. That's a heavy meter and that comes off too easy. But here you have hard plastic, and also you have an optical reader, so you do have the option of a computer interface here. There's 4 screws that hold it on. Here there's 2 screws, and the battery compartment, there's 2 plastic ones. I think there's at least 1 screw. There's probably a couple screws down here that holds the case together. But this stand, by the way, is just made very poorly. You can see this one broke off just by popping up all the time. It just finally broke off. But yeah, it doesn't have power up information. It does have fuse information, and it does have the battery information. 4 AA batteries, and it does have the little lip to get your finger underneath, and it does have the little rubberized thing here at the bottom. And the Hioki has a little thing for the finger, and it has the big rubber thing here for the bottom. Has the information for the kind of fuses you use, the high rupture fuses. 630 milliamp, 11 amp. The CE mark. So it has the fuse or the battery information. AA batteries, 4 of them. And it does have this information back here about power up sequence. So that's really nice they add that. I mean, I don't know why all meters don't do that. It looks like 2 screws here takes off this whole piece here that comes all the way down here. So we'll look at that in a moment. But they're rubberized cases integrated into the case. They're not the peel off holster type. So that's nice. As far as protection on the display, you can see that the Fluke is inset into the rubber here. So this protects the face. But then it comes flush right here, which is, I don't know why they did that. Where the Hioki, it has the ridge all the way down, down into this area. So it kind of protects the buttons and the display all the way down. As far as the buttons go, they're both kind of that silicone fill. Now I can tell you the Fluke is well used, but they usually don't wear out. But the Hioki definitely has a more rigid, like solid feel to them. These are just soft and they feel doughy, if you know what I mean. And yeah, the Hioki just feels a little better. The dials on them are very similarly made. They stand up about the same amount, and it makes it easy for gloves to get in there. And they both have the indicator on the dial, which is, the very similar construction actually. I mean, design. This one here, this is well used. Like I say, you can see it's had some damage right here on the terminal, but the metal down here is split, and I think that's to sense the leads. On this, they're not split, they're solid. So I think that's going to be more rugged. But what's really nice about this is instead of sensing and telling you you're doing something wrong, if you put this in current and then try to read voltage, if you're in current, it opens up the right ports. See that? When you're in amps, you have to be in amps. So if you're reading current and you try to go over to voltage, obviously you can't do that. So that's the best protection method right there. You just physically can't put your meter in a bad situation. Like I say, they both feel about the same weight and everything, same size. They both. That's why I like this Fluke 189. It's not oversized. It has a relatively nice display for a Fluke. Single line, so common. But look at all the digits. Okay, let's get some batteries in here and start comparing that. But I think we're going to see a nicer display. By the way, as I put the batteries in, I got to put a plug in for this screwdriver. I'll put a link down below. I appreciate if you use those links because it helps support the channel for free. But this is such a nice screwdriver. It has all these bits in the handle. They're, it's a bit on each end, and you just push them through. It's so nice, and it locks them in place. When you pull this down, just pops them in. Anyway, I just had to put a plug in for this. It's a ratcheting bit, which is what I wanted. So just so nice. You just move this and it ratchets. Move the other side, ratchets. You put it in the middle and it locks both ways. So yeah, just nice screwdriver. Okay, let's take this off. And get my fingers down here again. Okay, let's take this off. Wow, the screws are captured. You don't see that in a lot of meters, but high-end meter, you should, right? I'm still impressed. Wow, look at the compartment there. That's impressive. I like that compartment, guys. Obviously, the high rupture fuses, they're both physically large. Sometimes you see a narrower one on the lower current, but in this case, both physically huge. Totally isolated from the battery compartment. Battery compartment's isolated from the circuit board. You don't see the circuit board down through, so even if you got a leaky battery, I don't think you're going to damage your board. Here's two more mounting screws down in here. And look at that, metal inserts to hold the battery compartment on. Wow. Now, again, just look at this, I see all these channels, right? Tons of channels. Like down here. And look at this, when you see this rib? That first rib fits down in there. The second one fits down along the fuses. So just double walled, tons of protection. A couple features here to hold the fuse in place, right here and here. Same here. Little features here to hold this fuse down and put it in place. And also another little wall right here that comes down in here. So those fuses are high rupture fuses, but then they've got a really nice compartment to keep them inside in case it did rupture. That's just an extra buildup of plastic right there in the middle. I assume that would lay right across here. Maybe that just helps hold these. I don't know. That's interesting. But you can see this wall that all the way up here, how deep it is, comes up all the way around the battery. So, man, everything is just... And these, by the way, you see the integrated rubber? But this is very solid and stiff. That's impressive. And you got your little plastic catches here. They're pretty thick. And that's what's going to fit down in here. Hold the bottom in. But also the fact it's curved and it has those walls. So it's all, it's in there solid. Another shameless plug. I like the magnetic tips on these too, because when you're reaching down in here, pull these screws out, it's really nice. Alright guys, I just thought for comparison, take the compartment off for the Fluke. See the deep walls, how it fits, all that. And the little plastic screws, how it comes off. And here are the two screws that helps hold the back on. Now in the Hioki, I found it had an extra set here. The other thing that's obvious, we got 4 of the same size battery, all in sequence here. I'm going to take them out, and it tells you which way to put them in. Same as over here. There's little wells, so it's going to hold them securely. Over here they have these features here that holds the battery securely. Here you have this kind of spring versus this kind of spring. So some differences, but some similarities. Both large high capacity fuses. See the circuit board underneath them, same as on the Hioki. Now one thing I noticed on the Hioki is there's a piece of plastic underneath this fuse here. This is a lower current fuse. That might be for some isolation for some voltages that are on the board underneath. Over here I don't see that. I see those features holding the fuses in place. So a lot of similarities in the construction. Not near as much detail as they went into as in the Hioki with all the different walls and that. A little more simplistic on this guy, and with just the plastic screws holding this all together. Just a comparison, right? But what I did kind of want to point out is this foam that they use to go on top of the batteries. This stuff is really cheap foam, and some of the old Fluke meters, you'll see this stuff is just crumbled out. It just falls apart with age, but it doesn't rebound. It's, I don't know. I just don't know how much good it is. I guess if you have a plastic case and if it doesn't fit really tight, because you have these kind of things that hold it, just kind of a twist lock versus something that holds more secure, maybe you could hear the batteries rattle, and so they put that there. But yeah, but still, that's kind of a cheap material to use. An interesting observation, when I pulled these fuses out, they're just heavy. But these Holley fuses over here, I just felt how heavy these were, so I had to pick up the Flukes to kind of compare. And the Holley fuses just feel like solid and heavy. This fuse is heavy. This guy's a little bit lighter. You can see it's a little bit different construction, a little bit smaller fuse. It does say 10 amp down here on the board, 440 milliamp down there. You can see how they're soldered to the board. It's one terminal on each side soldered. You can see on the Hioki there's 4 solder points on each one, and obviously you can tell from the solder joints down below. Look how that's almost welded. That looks perfectly clean. 11 amps, 1000 volts. On here in the plastic, 630 milliamps, 1000 volts. Alright, so I had to pick up the Fluke and kind of pry it apart, loosen it. The Hioki feels like it comes apart really easy, probably because it's brand new. But here, let's take them apart now. I gotta shake these screws out. Oh, look at this. This is an old used meter. That post is broken, so it's right here. I was gonna say, wow, it's captured screw, but it's captured because the plastic I'm gonna glue that on. But this one, now it feels like it's gonna come out. Yeah, there it goes. So it does have this calibration seal. I don't know what the heck that's all about. Huh. Yeah, I don't know what the heck. Looks like I might make contact down there. Maybe there's something in the meter that says, oh, it was taken apart. Now here's a little 4 prongies to make contact with the board right here. I'll clean those up. They're a little dirty too. Shield, little piece of rubber foam. That's a better rubber foam than this stuff down here. This one has rebound, retention, still soft. That really foamy stuff down here, you know what I'm talking about? That stuff's garbage. There's a little ribbon cable right here. Looks like there's a little battery. That's probably the guy that's going to tell on me that I opened it if I cared. Talon capacitors. Okay, so let's go ahead and open up the Hioki. Wow. I'll squeeze them together so you can see everything here. Okay, so it's got a big protective screen here. Now here's its battery contacts. It looks like they're gold plated versus these little guys here on the Fluke. Pretty nice, guys. There's your optical inputs. So I guess the LEDs are right down in there, and it makes contact to the board right down there on those pads. Man, look at all the features on this plastic, all the ribs, and that's for the other side of it. On this side, I don't know. I mean, it comes down to the board, it isolates all this high voltage stuff. Holy smokes. Look at that big gas tube right there for input protection. Yeah, that's a PTC right there. And then there's a through-hole carbon resistor. Well, it's probably not carbon, it's probably metal oxide. And then look at that array of surface mount resistors. Man. Okay, we have, here's our high voltage resistors here coming up the line. Bunch of little surface mount resistors right here. So just kind of showing you the comparison, just, you know, build quality. A lot of people are always trust Fluke, and they're always, you know, not sure about other brands. So I just want to compare it to a Fluke. Okay, I'm going to take this guy off. Again, it's a captured, I mean, it's a metal insert here. But I want to show you something I can see. It's got a metal, look at that. It's got an insert here to protect the plastic to keep it solid, and then it makes contact down there. Also, I think it's passing, you know, this big trace, I think it's part of the shield that comes up, and wow. I'm wondering if this plastic has some, you know, maybe you guys know, I wonder if it has some kind of shield properties built into it, because there's something about it that looks weird. It's got kind of a metallic look to it. So I'm thinking this is a shielded plastic, and it's making contact with this metal down into this. That is the first time I've seen that. Wow, what the heck? Alright guys, that meter is nuts. I'll get a close up here of the board, okay? Okay guys, I took off this little shield, so it's just shielding this chip and some of these, I think these are capacitors here. There's a tantalum capacitor. It's shielding that part of the circuit right there. Had this little metal clip here on the corner that catches that board, so you kind of have to just pull that away. But yeah, that's the shield right there. It's probably a mu metal shield. And if I pull over the other Hioki here, if I hold these gold plated leads together, and if I hit relative 0, and I hold them together again, okay, 0.1, 0. So you see some ohmage right there. Okay, now here's something interesting. I was really curious because I'm almost positive this is some kind of shield, and it might be a painted on coating, I'm not sure. But let's go ahead and I'll make contact with that piece of metal. Look at that, 140 something, 100 ohms. So yeah, this is some kind of shield here. It's impregnated or something with some kind of carbon, metallic, I don't know what it is. But if you guys know, let me know. That is really cool. Okay, I just want to give you a close-up of the Fluke. And this is the top of the board here. It does look like a power supply, maybe a transformer up here. These yellow and black things are the tantalum capacitors. That's what you'll see in high quality meters. You won't see aluminum electrolytics. Here's a little onboard battery, which I wonder what that costs when you have to replace that guy. There's the chip, and this is where the shielding, the mu metal shielding went. There's the contacts for the battery. You can see these little resistors here. I'm just a little surprised how small they are, because I would have thought these were high voltage protection, but maybe not. Now here's the clips. You know, there's 2 solder joints per clip, and the 10 amp marking on the board. Some of the cutouts for voltage isolation, and there's the bottom of the board. And you can see where the terminals are soldered to the board on the back side here. Okay guys, and here's the Hioki for you chip aficionados. Maybe you can tell me what that chip is. I mean, well, I know it's the brains of the operation, but maybe you can tell us something about it. You can see the LEDs down here for that optical reading, and this thing has some really interesting parts. I don't want to touch anything here because I don't want to get my fingerprints on anything. I'll explain why. See those interesting rainbow colored thing? I wonder if that's coming through on the camera. But these are capacitors. See these kind of green and purple ones? I think they're really high precision capacitors. I hope the color is coming through so you can see what I'm talking about. But really cool laid out board. You see the no handprint right here? No fingers there. I think these green resistors are really high precision resistors. That's what you find in the, you know, to get the high accuracy in these high-end meters. And same thing over here. Another hand, no hand here. So be careful not to touch anything, but yeah, so you see the green resistors, I think, throughout the board. Here's the pad where the shield came down. And if you notice, I don't see any tantalum capacitors. All I see is ceramics, which it's really nice because they're really stable over temperature and that. But especially if you notice some of the sizes of them, like that guy there, they're just huge. Some big ones up here. Anyway, looks like a power supply up here at the top with this inductor. Maybe another one down here. There's another inductor right here. That's the terminals where the battery makes contact. As we come down, you can see the 4 contact points. They almost look like they're welded. They're so clean, I don't see any solder. You can see the indication for the type of fuse on the board, the current and the voltage, F2, and the large surface mount resistors here. Very, very nice. Even though this small one's also on the plastic, it's shown here on the board. That plastic's probably part of the barrier design, but look at that big old tube down in there, Z1. Those are really nice. The PTC and the I think that's a metal oxide resistor. They kind of replaced carbon resistors a while back. And also, you notice how the terminals are all labeled. That's nice. And as well, the terminals are huge, right? Very nice design on the terminals. So, yeah, that is impressive construction, I think. I'm not exactly sure how this thing works, but there's multiple pieces of this plastic, it looks like, that holds this, the turn wheel down. So, we're going to have to look at this and be very careful taking it apart. Okay, this is the Fluke, the front case with the board removed. Here's the buttons that come through, the carbon pads on this side that make contact with the board. And you notice this? That looks like another painted on shield that makes contact here to the board. So, yeah, Fluke's using some of that similar technology. Now, you can see the little prongs, double prong on each, contact here. So, yeah, that's what Fluke's front cover looks like. Which, by the way, there's that broken terminal. Yeah, they don't look like they're super strong. And by the way, this is kind of a rubber, you can feel the rubberized seal here where it mates to the board to try to keep the dust and grime and probably even a little moisture maybe. It's just a very small seal. But anyway, yeah, if they would have put some plastic ribs against these things to the wall, they could have made them stronger, so this one maybe wouldn't have broken. And the Fluke top side of the board. You know, you can see where all the contacts come down for those little carbon contacts for the push buttons. And here's their resistor, their high tolerance resistor, which I think in Hioki was those other resistors we were looking at. This is on that ceramic or kind of a beryllium substrate. And then there we go. Here's a big high voltage large through-hole resistor. That's actually a carbon. You can tell the difference, right? Plastic versus kind of that sandy, gritty look. Kind of like these. And here's our diode bridge for the current. Another large resistor. And again, you can see the cutouts. And there we go with our little current shunt there. The Fluke 189 has always been my favorite Fluke meter, but now I'm kind of wondering if this is why they stopped making them. This piece right here you have to buy separately. I think it's just a poor design. This one here, I tried to heat up the joint on the other side and it's still really loose. So there's something kind of messed up on the other side. So I think I have to remove them all, take this thing off and see if I can repair that. Or really what I need is just replace this, because here's something else I've seen. It looks like somebody's already broken this one down here and then epoxied this to the board. So this is, I thought the solder joints on these things look pretty bad with the flux, but I think someone's had to repair these before too. And so, yeah, this meter's just been abused, I think. You know, people think it's a Fluke, it'll last forever and you can do what you want, but no, you still have to treat them right. And yeah, so this might have been not as rugged as you'd want on an expensive meter like this, and maybe that's why they stopped making these. But yeah, that was my favorite meter. Alright, so I almost forgot to talk about the protection. There's a couple blue MOVs. Blue's usually EPCOS, and I can see from the symbol that they are EPCOS. The red is usually little fuse, and I can see it says LF, it is little fuse. Now in MOV world, these are small, they're kind of fat little guys here, but for multimeters they're usually kind of small. Sometimes you see big ones. This guy here looks like a PTC, right? That's what you'd expect. But the black kind of gave it away. So I brought over my multimeter because I wanted to check. Here, let me show you this. Now, a PTC is a resettable fuse. So it starts off like 0 ohms and then goes high ohms as it gets hot with current going through it. This guy's 1.2K. So he's an NTC. He's negative temperature coefficient. So what they do is they kind of stop inrush current, that kind of thing. Then as they heat up with current, then the resistance goes down, maybe down to 10 ohms or something. The other thing I can tell you, you might be able to tell, the trace work, you see the little black lines in the board? They are teeny. I don't even know if they're 10 mils. So that is a teeny trace. So they're not, these guys aren't meant to handle a lot of current. Now the one thing I was talking about, this little painted on, shield here with that little button right there, that makes contact right there. And then we have a screw pad. So yeah, that's your shield. There, for some reason, they thought they needed to shield these buttons. So I think that's interesting that they just chose those three. Must have had a problem with them. Usually when you see that painted on shield, that's something where you found in test that you have to fix. And just point out, here's the Fluke opto guys that go through this little window right here. Alright guys, I saved it for you. I took the 4 screws out of here and 2 screws up top of the board, and hopefully that's all I need to do to pull this guy out. And sure looks like it. Again, I'm going to be very careful not to touch the board. Whoa. Don't want it to fall apart on me. Uh-oh. Stuff's falling apart. Okay, this little plastic wheel came off. I'm going to put my finger on this plastic here. Wow, that is crazy. This looks like that same material. So it's shielded on this side too. Wow, that is some very crazy technology. Oh my heck, that is, I am so impressed with that. As a power supply guy, I'm always trying to figure out how to shield things, and this is nuts. I've never seen this before. Okay, I was pushing on that. See how it started coming up? Okay, you see the little bushing like that was on the other piece? So that's how this plastic makes contact to that terminal right there. I see a little arrow here. Hopefully I'm not going to have trouble. Oh, and there's an arrow right there. Wow. And there's an arrow right there. I'm wondering if I'm supposed to line up all these things. Oh my heck. Okay, I'm not going to try to remove that. It's going to the board and it's stuck on the other side of the board. Holy smokes, look at the, this is used to, and look, it says do not touch. So I am not touching any of that stuff up there. And the board is very well, look how nicely the board is labeled and everything. Super impressive. Okay, there are the solder joints for those fuses. So they are soldered on this side, all 4 spots. Very, very clean. Very nice construction, guys. There we go. Try to get my fingers on the edge. You can see the labeling on the board. Super impressive. And you know that display, it's, I hope the camera picks that up, but it has a very interesting, uh-oh, losing that plastic. I got to touch it by the edges. I'm grabbing the fuse and the edge of the board. But that display has like an ocean water kind of look, if you know what I mean. It very, I don't know, something very clean about it. It's a very interesting display. I see a few ceramic capacitors up here on the top. Alright, that's crazy. I'm going to put this back together. Okay, I just wanted to show you that was very easy to figure out how to put that plastic back on because of all this interesting, intricate cutout work. It just fit perfectly in there. And this piece here, you can see all the intricate features and how it fits down in here. Just crazy. Part of those features I'm talking about has these 2 plastic pieces snapping together, locking together. So, I mean, they are tight. They don't wiggle around. There's very little movement of these pieces. You know, one thing I wanted to note is I noticed a little bit of oil, a little grease on top of this. and then I noticed a little bit on this thing here. So I think underneath this, the as it turns, you know, it's mating to the board with a little bit of that grease compound. Honestly, I don't know the advantages or disadvantages of using grease or not using grease. I know some people think it's a great thing. I'm not sure exactly why. One thing I could imagine is that if you can keep the contacts clean from not getting oxidated, which like on the Fluke, I noticed some oxidation. Now a lot of this is gold, so it doesn't get oxidized, but on the fuse, well, I have to show you on the other side. And actually these terminals look very clean. I don't see any oxidation on those. So that looks very clean, even though there's no grease. But now these fuses, a little bit, and they're kind of bent out of shape a little bit. So whoever used this meter in the past obviously wasn't very careful with it. They thought it was a fluke and they could just do what they wanted, and obviously you can't. Yeah, now I see it. As I look down on this part of the case, I didn't really look at this close before. As you look down in here, you can see the little buttons, and you can see the little plastic, this little piece here. Very interesting. I haven't seen this before. Very interesting. It holds the carbon things in a little funnel, so it's just not flopping around like you see so often. See what I'm talking about? Now, these little white things, what the heck are those? Wow. Okay. Yeah, I see what they are. Those things have come out. They're supposed to sit in here, and they must keep some kind of separation between this piece and that piece. If you see what I mean, there's two spots here. I was wondering what those features were, because well, oh, I see. This guy is, oh, that guy's covering, oh, I see what's going on. Okay, so there's a couple of screw terminals here if you want to remove this cover here. Wow, what the heck is going on here? So there's another this plastic features another thing that gets removed along this pad, and you have to take off these little caps, and I think that's to keep dirt and dust from getting in. I'm trying to be careful not to touch things, and shoot, I'm going to pick that up with tweezers. Just trying to be careful here. Okay, so then this guy popped off, but I can see the two little holes, so I gotta look at this very carefully and make sure I put it on right. Okay, one side, I'll experiment. Okay, yeah, that's how it goes. So there we go. Wow, this is just crazy. Now it's lined up, so I can just put that down because I haven't moved the knob, so I'm not going to move this around much. Let's see if I can sit that down in there without screwing things up. Alright, sorry, I had to use both hands and be very careful, but it just kind of sat right down in there, no problem at all. So, alright, I'm going to flip it over, make sure the dial's adjusted, and before I button this thing all up. Okay, it feels like it's going through all the locations. Yep. Oh yeah, part of that mechanism underneath was this wiper blade thing. Okay. So there we go. Woo! One little tip, guys. Put all the screws in whenever you take something apart, like your wheels off your car or whatever, and then before you tighten any one of them, make sure they're all in, and then slowly cinch them down close to where, make sure everything's seated right, and then start tightening things. But I can tell you this fits like a glove. I mean, everything just drops right into place, so I'm pretty confident here. Wow, I just want to show you this, guys. This is really neat how this went in there. Now, can I get it back out? But this guy right here, this feature here, fits right down into that little pocket there, just perfectly. And this piece from the top side and the plastic from the bottom side is the one that this slides into, is a piece from the bottom side. So, and then we have this little hole here that this guy fits on. This little boss fits over that. Another one up here. and then this is a little collar that makes contact with that. So all just super nice, and just everything just drops into place. Wow, look at that. They're color coordinated too. So Japanese meter made in Japan using Japanese batteries. I mean, these guys, I wonder if these Holley, I wouldn't be surprised if the Holley fuses are made in Japan as well. But yeah, they're definitely locked in. There's no movement at all. So if meter drops, yeah, those fuses aren't moving. I just want to point out one more cool feature. As I'm putting these screws in, the ones down in here and the four corners, they're all the same screw type versus, you know, how Fluke will often do it where, you know, every screw is a different screw. So that's really neat too. Also, you notice how long these guys are? These are a little shorter. They go down in deep, and you don't need a zillion threads to hold something on. And I just can't help but notice the attention to detail on everything. There's so many things to point out, but even the screws here, they're made for slotted or Phillips. So whatever you happen to have, you know, it's designed to make it easy. And you know, of course, the brass inserts, and you can see how, whoops, fit in the heel. See how everything just drops into place. All right, guys. So so far, looking under the hood, pretty impressive in there. A lot of attention to detail. Just, it's got a nice feel to it. I don't know if I pointed out, but the curvature on it, it's kind of like this one. It protects the, you know, when the corners hit, it doesn't hit the bottom. You don't have a blunt hit, it's going to hit the corners. And so just a lot of attention to detail. It's hard to point out everything. And next video, we're going to do some testing. Okay, I'm going to show you the DB functions, show you some of the other features this guy has. Let me know if you like this format, and give me your comments. Thumbs up to the video if you like the video. If you don't like the meter but you like the video, alright guys, appreciate it. I want to thank my patrons for all the support, and for, you know, the what happened last weekend, the thing, yeah, then on vacation, yeah. Anyway, video's too long to talk about my stuff, but appreciate all you guys. I love to comment on the Patreon board, kind of explaining what happened. But yeah, I really appreciate all the, you know, good wishes and all that kind of stuff, guys. So I like doing this channel, it's fun. So probably should take a rest, but anyway, I'm kind of just going slow. Sorry about that, and I'm gonna try to build up and get more videos out. But okay, so we'll see you next time, guys. Thanks for watching, thanks for supporting the channel, and catch you next video.